In a groundbreaking development for military aviation, the U.S. Air Force successfully tested a fighter plane piloted by artificial intelligence in 2024. This achievement marks a significant milestone in the integration of AI into combat scenarios, showcasing potential for autonomous systems to revolutionize air warfare. This article explores the journey that led to this historic event, the technology behind it, and the implication for the future of military aviation. The journey to having an AI-piloted fighter jet began with the Defense Advanced Research Projects Agency's Air Combat Evolution program initiated in December 2022. The ACE program aimed to explore the capabilities of AI in piloting combat aircraft with a focus on enhancing operational efficiency and decision-making in high-stakes environments. The program's initial phase involved extensive simulations where AI algorithms were tested in virtual dogfights against human pilots. These simulations were crucial for developing and refining the AI's ability to handle complex aerial maneuvers and combat scenarios. The AI systems were trained using machine learning techniques, including supervised learning, unsupervised learning, and reinforcement learning, to build a robust database of moves and counter-moves based on historical dogfight data. The centerpiece of the ACE program was the X-62 Vista Variable In-Flight Simulator Test Aircraft, a heavily modified F-16D Block 30. The X-62 Vista was equipped with advanced sensors, a model-following algorithm, and a system for autonomous control of the simulation developed by Lockheed Martin Skunk Works and Calspan Corporation. These upgrades allowed the aircraft to mimic the performance characteristics of multiple aircraft and facilitated rapid software updates to keep pace with AI development. The X-62 Vista served as a primary testbed for the AI systems, enabling real-world trials that went beyond virtual simulations. The AI agents were initially tested in defensive maneuvers before progressing to offensive and high-aspect nose-to-nose engagements. These tests were conducted at Edwards Air Force Base in California, a site renowned for its aerospace advancements and historical significance in military aviation. In September 2023, the AI-controlled X-62 Vista engaged in its first real-world dogfight against a human-piloted F-16. This event marked a significant milestone, demonstrating the AI's ability to perform complex combat maneuvers in a dynamic and unpredictable environment. The AI-controlled jet executed lightning-fast maneuvers at speeds exceeding 550 miles per hour, subjecting the human pilot to forces up to 5 times the force of gravity during the dogfight. The AI and the human pilot engaged in close-quarters combat with the aircraft racing within 1,000 feet of each other, twisting and looping to gain a tactical advantage. The AI's performance was nearly on par with that of an experienced human pilot, showcasing the potential for AI to handle complexities of aerial combat effectively. The success of the AI-piloted fighter jet was made possible by several technological advancements. The AI systems were built on machine learning algorithms that could analyze vast amounts of data and make informed decisions in real time. The AI agents were trained to comply with safety and ethical requirements, including flight envelope protection, aerial and ground collision avoidance, and combat training rules to ensure safety. During the test, a human pilot was always on board, the AI-controlled aircraft ready to take over if necessary. This safety pilot could deactivate the AI system with a push of a button, providing an additional layer of security. The AI's learning process was also carefully controlled, with new data gathered during flights, fed back into simulators to refine the AI's performance. The successful test of an AI-piloted fighter jet has far-reaching implications for the future of military aviation. The U.S. Air Force plans to deploy a fleet of over 1,000 AI-enabled unmanned warplanes by 2028, with the first of these aircraft expected to be operational within the next few years. These AI-controlled jets are envisioned to perform a range of missions, from providing cover for manned aircraft to conducting autonomous combat operations. The integration of AI into military aviation offers several advantages, including enhanced operational efficiency, reduced risks to human pilots, and the ability to handle large amounts of data in complex combat scenarios. Combat AI-controlled jets do not suffer from fatigue or fear, allowing them to perform consistently under high-stress conditions. Additionally, the cost savings associated with smaller, cheaper AI-controlled unmanned jets make them an attractive alternative to traditional manned aircraft. However, the use of AI in combat also raises ethical and legal concerns. Arms control experts and humanitarian organizations have expressed concerns about the potential for AI to make life and death decisions autonomously without human oversight. The U.S. Air Force has emphasized that there will always be human oversight in the system when weapons are used. But the debate over the ethical implications of AI in warfare continues. The U.S. Air Force's successful test of an AI-piloted fighter jet represents a significant leap forward in military aviation. The integration of AI into combat scenarios has a potential to revolutionize air warfare, offering enhanced capabilities and operational efficiency. As the technology continues to evolve, it will be crucial to address the ethical and legal challenges associated with AI in combat to ensure its responsible and safe use. The future of military aviation is undoubtedly being shaped by these advancements, and the journey has only just begun. It was only in 2022 that the experimental aircraft was first uploaded with an AI system and launched into the first series of test flights at the Edwards Air Force Base in California. This year saw the first ever deployment of machine learning-based autonomy in flight critical systems, and the results of these tests will provide serious insight into the future of combat aviation. So if machine learning can operate effectively in an environment as dangerous as air-to-air combat, it has great potential to earn the trust of humans during its dogfight exercise against human pilots. The X-62 relied on what the military calls non-deterministic artificial intelligence and started with defensive maneuvers. But as the test progressed, it switched to attack mode, reminiscent of real aerial combat scenarios, moving at speeds of 1,200 miles per hour or about Mach 1.5. During the test, the AI-piloted jet came within a range of 2,000 feet against a human-piloted F-16 as part of the offensive high-aspect nose-to-nose engagements. Notably, the AI handled the entire sequence on its own without requiring any kind of human intervention. A press release from Edwards Air Force Base announced, "The X-62A is flown with safety pilots on board with the independent ability to disengage the AI." However, test pilots did not have to activate the safety switch at any point during the dogfights over Edwards. But according to Chief Test Pilot Bill Gray, integrating all that skill with proper combat and safety protocols wasn't an easy task. "We have taken the entire simulator laboratory and crammed it into an F-16. DARPA suggests it could be more versatile than a human pilot, and that's because the AI program is malleable and can ape the characteristics of other airborne combat vehicles." In short, the progress on the X-62 project has been nothing short of remarkable. In just a few years, the experimental vehicle has managed to go from simulation tests and lone flight to engaging in combat with a human combat pilot without running into any glaring flaws. The trust and capabilities of the X-62A and the AI stack powering it has certainly elicited trust from not only the teams working behind it, but also defense leadership. According to the Associated Press, Air Force Secretary Frank Kendall told senators that he would hitch a ride in one of the autonomous F-16s to test and prove their efficacy. Just a few weeks later, he did just that. Yet, there's more to the X-62A project than just testing machine learning's combat capable. The Army is planning a whole fleet of what is called collaborative combat aircraft that will play the role of loyal wingmen to a human pilot. If you liked our video, please hit the like button and subscribe to our YouTube channel.